Okay, we are live. Hello. Um, Let me just see where we are here. Say hi in the chat if you're watching along. So, let me just see here. So, today we are going to do a little session which has been set up as a component of the Architectural Drawing and Representation 2 class at Columbia that I'm co-teaching with a handful of amazing folks. And we have been doing some kind of like webinars just as a way to do kind of like technical instruction, in this new moment we're having to get a little bit inventive to, kind of get people engaged with technical instruction and all of that stuff, and it's just kind of fun. So this is not a required webinar for students, but hopefully we've got a few joining. I see Adam. Hey everyone. So I think the course that we're doing is doing a series of kind of like themed weeks where the students can build drawings or drawing experiments week by week and add them to what we're calling our quaranzine. And this week's theme is collaboration. And so that's why I thought it would be fun to dive into some topics around collaboration in Grasshopper. And yes, no drinks today. It's a little early. I have my coffee, but it's not spiked. We'll I don't know. Maybe later on we'll take a break and I'll drop some whiskey in it or something. I can't do all my webinars drunk, or that just becomes like my thing. That's not cute. Anyway, so I wanna kind of go over a handful of pretty quick examples. This is gonna be less like big in-depth definition spinning today, and it's gonna be more about just kind of like peeks at some strategies. And I'll show you kind of some plugins, some external tools, some approaches, some ideas about ways to use even native features of Grasshopper to collaborate in kind of new or different ways. And I'm going to kind of go through them fairly quickly. But please feel free to drop any questions in the chat. I will try and respond to those as they come up. There's like a little delay, so it may take me a second. But yeah, that is the plan for today. Let me get my screen going. I think it's actually like up. Yeah, it's back here. So let me just make my head a little smaller. Always a feat. Okay, so that looks good. Let me just, whoops, sorry. I'm not very good at this software. So I want to start with collaboration strategies that are more akin to things you might actually use in professional practice. And then towards the end, we'll shift gears towards slightly more inventive, fun, impractical ways of working together. And yes, Kristen had a great question, which plugins we'll be going over so we can download them before. So probably the biggest one, which you are not required to install to follow along because I'm not going to show it in great depth, but if you're interested, is Speckle. I'm going to show a little bit of Speckle. And then the rest of what we'll be seeing today is going to use, let me just write these down. I don't know what, but I'm sure we'll be using some human because I always do. We're definitely going to be using JSON. We're going to be using a newish plugin that I haven't really talked about except in the context of this class called CS Vulture. And we're going to be using, what else? Probably some Wombat. I often drop some Wombat in here. I think that'll probably cover it. We may get a little fancy later and do like some MetaHopper. but I don't actually have like an explicit plan for that. But of course, I'll probably prove myself to be a liar and like forget about half of these, and I'll just mention them when they come up. But everything included in here that you will need is available on the Rhino package manager, and that is how I would recommend getting it. So if you are on Rhino 7 whip, you can just type package manager over here in the Rhino command line. And if you are on Rhino 6, you can type test package manager, all one word, and it looks like it's not going to work because it's like a secret hidden command, but in fact it will. So if you want to install human, MetaHopper, actually you probably don't need MetaHopper. CS Vulture is on here. What else did I say? Wombat is on here, and JSwan should be on here as well. And those are the big ones that we'll need. Thank you for that suggestion, Kristen. That's a good idea. But I'm sure I've forgotten some, so I apologize. So in fact, a lot of what we're going to be using today is actually sort of like weird or different ways of using existing tools within Grasshopper. So I'm excited to share some of those with you. So in fact, the first thing that I wanted to go over, because I think that like one of the challenges with working with Grasshopper in a professional context is that it's actually really hard to collaborate with. It's not a very sort of like inherently collaborative environment. It's hard to have multiple people owning a Grasshopper definition. It's hard to have multiple people developing and building code in Grasshopper together. There's no notion of things like source control. I mean, theoretically, you could throw your Grasshopper definitions into a Git repository, but because it's not, text parsable, it's really not useful. And I've seen some people do this with like the XML from Grasshopper. Don't do this. It's a terrible idea. You should never save your files as GHX. So these are some strategies that, I and colleagues of mine have developed over time to ensure a kind of seamless or smooth collaboration. So one of the key things, and this is the most boring of everything I'm going to show today, is just annotating your definitions. Like being really clear about what things you want to be designated as inputs and outputs, what things someone is meant to use. And the tools that we have for annotation in Grasshopper are fairly simple. There's the panel like this that I just used, which you can grab from here. This is great for any kind of longer form notes or instructions. You can make it look pretty. You can give it a title like README and drop in all of your notes and change the formatting and all of this other stuff. So wherever I would create like a comment in normal code, I would probably put a panel which kind of describes, why I did something or anything that someone using the definition should be expected to know. So panels are really useful. Groups are also really useful. So if I open up a file, and I'll share this directory with you all in a moment here, but let's just pick an example. If I wanted to share this with somebody, oftentimes what I'll try and do is find the groups of components that sort of functionally are responsible for one thing, and I'll group them. So Control G will make a group around your components. I've seen a lot of firms do a kind of color coding around their groups where like certain groups mean certain things. You can get really fancy with that. You can use MetaHopper to automatically apply colors on the basis of like a prefix. You can build templates. But for all intents and purposes, the most important part is just designating your group. So what does this do? This creates a twisty tower. And I always make sure that my inputs are pretty obvious here on the left and my outputs are pretty obvious here on the right, imagining that like the group is sort of meant to be thought of as almost like its own component. And in fact, we'll be looking at clusters today, which are another way to take a group of code and sort of condense them into single sort of like pseudo components. The one other thing I'll say, okay, so it turns out we will be using MetaHopper now that I think about it. One thing that I like to do when I'm creating a definition for somebody else and keeping it organized, MetaHopper will allow you to best practicize a group. Now, what does that mean? Best practicizing will add params at the front and the back of your group to designate any of the inputs and outputs. And then that's sort of an encouragement to label these. So this is the radius, this is the side count, this is the height, and this is the twist. And so when I'm sharing a definition with somebody, it's a really good habit to get into to kind of like label everything that's going into any sort of functional group and everything that's coming out. So these are this sort of like tower faces or whatever. And we'll see through some other workflows today how useful it is to get into this habit. So I'm not going to bore you with a bunch of annotation stuff. The one other thing that I'll say is I like to create scribbles, which are, they're somewhere up here in util. Yes, scribble, which is just basically a big piece of text. So I'll say, you know, this is the twisty tower portion of my definition. I can make it really big. And one of the things that I like to do is when I've got all my named groups, there's another MetaHopper menu item. This only works on Windows, called Label Selected Groups with Scribbles. And this will take all the groups you have selected that have kind of like titles, and it puts a much larger scribble in the corner of each group so that it's easier to see from a distance what every group is responsible for doing, because those little labels go away. So that's just a little tip. One of the things that I've seen a lot of people do at firms, and I think is a really good general practice around kind of collaborating with Grasshopper, is taking little reusable functional bits of code, turning them into clusters, and then turning those clusters into user objects. So let's go over what both of those concepts mean. So a cluster is what happens when you take a group of components and you can right-click the canvas and choose cluster. And this basically condenses all of that logic into a sort of pseudo component. And you'll notice that if I was diligent about naming all of my inputs, then they'll come out the other side with, you know, a kind of clear label, which is a really good practice. So I'm just going to undo that. If I hadn't done my best practice step and I had only selected these before my cluster, I would have to do a bunch of manual work to get in here and like label each one of these. And so as a good habit, it's useful to, you know, kind of create your labeled inputs and outputs so that you are clear about kind of how your cluster is going to work. Even if you don't intentionally make it into a cluster, even if you don't, or if you don't intend to make it into a cluster, it's still useful to designate, like, these are the inputs, these are the outputs. That's what allows somebody else to get into this workflow and know, oh, that's what this piece of data represents. So I'm going to go ahead and recluster this. If this is a cluster that I want to use over and over again, then I can do that. Clusters make that really easy. The first thing that's really nice about this is that if I copy and paste a cluster, you'll notice that this cluster occurs twice in this document. If I hover over this cluster, it's actually an instance of a kind of central definition, which means that if I modify this cluster somehow, like let's just make, what should we do? Let's just add a fillet to our polygons. So I'm going to say, let's fillet all of the polygons before we, no, that's too big. Let's do 0.1. There we go. So it's going to round the corners of the polygons as I make my twisty tower. When I save that change to this cluster, it's actually affected this one as well. So even if I have another instance down here that has like a different number of sides, the original one up here has been affected by that change. I think that's a useful tactic. And the other thing that is especially useful with clusters is the ability to save them to your user toolbar as what we call user objects. So if this is my twisty tower cluster, then what I can do is go File, Create User Object. And I can now add this to a tab of my choosing. I'll call it, create twisty tower. I might give it a description. If I'm going to share it with my colleagues, I probably will. I might even give it an icon. I can drop a file in here or pick from among a list of other icons, which this is like a terrible interface, and it's impossible to find the one that you want. And it also takes a long time, so I shouldn't have clicked on it. Let's just make it look like this, which is not the one that we want. But in any case, I can give it an icon. I can click OK. And then wherever I put it in my toolbar, which I'm not even sure where I put it. I might have put it under user. Let's see. Create twisty tower. Oh, yeah. Is that where it is? Yeah, there it is. Create twisty tower lives right here. And anytime in any future definition where I want my twisty tower, it will have all of that logic. And it's still editable. I can still get in here and change it. Now, you should note that the change propagation only works within a given document as a rule. So if I make a change to the version of twisty tower in my other definition, it's not going to affect it in another document. We'll talk about that in a little more depth, but I just want to give a couple other pointers on cluster creation. One of them, and I'm going to undo a bunch because I usually try and set this up right at the beginning. You can do this after the fact, but I always like to get things kind of just in order at that moment. So if you internalize the data to one of your inputs, if you basically put like persistent information in it, this is fine to do if you're dealing with like basic values like numbers and text and stuff. For curves, or actually curves are okay. For large sets of geometry like breps, I would avoid doing this because it'll actually like save that geometry into your file and it can bloat your file size and make file saving really slow. But if you internalize this simple data, then when you cluster, it actually you'll have to reconnect these in order to have it, because whatever there's sort of an outside wire connecting to is what becomes an input. But the beauty of this is that now, because there was some data stored in those parameters, it actually comes loaded with a default value. So if there are sort of like sensible defaults that you want your saved functions to have, then you can load them in. And I think you can do this after the fact. I think you can also just go in here and like disconnect this. And let's say we want the default number of sides to be 6. You can save that value in the param, then wire back up the input. And if you ever need to edit this, you can add in a new input. So we could like add a fillet radius in here and hit save. And now this exposes that value. So now our sides default, if we were to make a new, is that true? No, I think in fact the reason why I always do it at the beginning is because that's the only way that change takes. So, or did I just? No, I did store it. Yeah, you actually have to do it right away. I bet if I recreate this input, then it will now have a default value for sides of 6. Yes, that's the case. So it's a little bit finicky, but that's a really good way to kind of set up your reusable functions such that you can kind of like provide the usual values, but allow a user to supply other values if they so choose. So I've gone ahead and I've created my twisty tower. Oh, the one other note here is that any changes after you've made the user object will not affect like the definition of that user object. So if you want to change the logic of your script, of your cluster, you'll have to recreate it from scratch. So if we made some modifications here, I'd have to actually delete this user object by right-clicking it. I'm not going to do this here. And then recreate a new user object, which is a little bit of a pain. This feature has always been kind of like half-baked.
Ah, molti italiani nel chat, eh?
In any case, if we go to, sorry, and that's the extent of my Italian. We're not gonna test that any further. if we go to special folders and open up the user object folder, then you'll see that creating a user object creates this file called the ghuser file. And what a lot of firms do is create central representations of, or like central folders where they'll store all of the kind of like shared definitions, all of their shared user objects, all of their shared clusters. And that becomes a really good way to have kind of like a library of code that anybody in the practice can use. And it's also a way to kind of like build up a project together with logic that you want to share from one version of a definition to another. We'll be looking at clusters a lot today. There are a lot of pretty interesting things around collaboration you can do with clusters, but I also just wanted to show the kind of like baseline functionality of a lot of this stuff. If you get a cluster from someone else, so like for instance, I probably have a ton of them in here. I'll just search for all my clusters in here, and I want to install them. Let's pick one like rounded heads up tag. That looks good. I don't know what this is or where it's from, but all you need to do in order to install it is either drag and drop it onto the Grasshopper window itself, and that should be sufficient. Oh, ignore me, Dropbox. Don't do that. Did that work though? Yeah. So now it's added to my list. It's shown up somewhere. And let's see if this actually does anything interesting. We're going to evaluate the box at 1.2. And we'll say hello. I have no idea what this looks like. And we'll set it to like 12. Do we have anything? Is this doing any? Oh, yeah. Oh, but you know what? It was built for Rhino 6, so the location of the text and the little background are off. What that's meant to do is create a little like background that hovers behind your text, but they made some changes with Rhino 7 about the like positioning of text, so it doesn't quite work. That's an old cluster, so in any case. So clusters are a really good way to capture some logic and share it with other people, and there are a few situations, though, and in fact, this was coming up in the chat. People were talking about clusters in Galapagos, and there are a few examples of this. Galapagos is just one of aspects of Grasshopper functionality that kind of like can't work with clusters or can't get into your cluster. So here's another example. Let's say we create a logic that creates a bunch of values and a graph mapper. And we're going to just like make a curve basically by creating XY, using the initial values as the X and the graph mapper values as the Y. And then we're going to create an interpolate curve through these values. So now this is like a piece of functionality that I've created that uses this like graph to control the shape of this curve. But I can't cluster this because if I cluster it, I can't get access to the graph mapper. So I might want to capture this functionality in a way that I could reuse it consistently, but I just can't rely on clusters because as soon as I cluster this, even if I were to say, okay, resolution is my input, let's say, and the curve is the output, like that's no longer useful to me. So there's another piece of MetaHopper functionality that I rely on in situations like this, which is sort of like a hack on top of clusters or on top of user objects, which is called snippets. So if you select a group of components like this, instead of clustering them, if you go to MetaHopper and choose Save Snippet and say, this is my graph mapper curve workflow or something, it's going to add itself to my user objects in the same way as a regular user object would. But when I place it on the canvas, oh, that's okay. That's all right. I think if I do it in a new document, it should be okay. Yeah. So then it will actually instantiate the entire set of components. And so, and the nice thing is that these function exactly the same way as clusters with respect to sharing. So if you have like a little mini definition that you use all over the place, including like a setup for Galapagos or something that you want to share with the world, then you can go to your user object folder, and usually I just sort by date. There it is, graph mapper curve. I can share it with anybody. They can install it exactly the same way as they would a user object of another kind. And then they'll be able to just create a new instance of this same set of components. So that's another way to kind of share reusable logic. For practical purposes, in a lot of professional contexts, you're going to wind up working with people who just don't want to touch Grasshopper. Like they want the functionality, but they just don't want to interact with the nodes and the wires or the spaghetti of Grasshopper. So one tool that I developed and have been working on, for many years that enables a new way of kind of collaborating with Grasshopper that involves someone who knows how to write Grasshopper and someone who doesn't, is to build a UI for your definition. So human UI, I'm not going to do a whole tutorial on human UI here because it is a, we could do that for hours. But I'm just going to show you the very basics, which are that with the human UI tab, that was a library that I didn't mention. Human UI will let you create an interface for your definition. So there are a few components that are necessary for every human UI definition. There's a window that you launch. So we'll create a window and we'll put a Boolean toggle to tell it to launch. And this is going to create a little empty window. If you want, you can give it a name like, Twisty Tower Controls or something. And then we have to add user elements, UI elements to this window to give it something to interact with. So we're going to go to the UI elements tab and do create slider. And the way this one works is a little bit peculiar. But what we'll do is we're gonna name all these sliders. Radius, sides, height is already labeled, and twist is already, although this will probably get unlabeled as soon as I disconnect it. So height, oh no, it's okay, twist. Here are my sliders. These I'm actually going to remove from the business logic, the part of the definition that does the work. And I'm going to plug them in instead to this create slider component. I'm holding down shift so that I can have multiple wires going in. And in order to, what this is doing is converting these sliders into human UI sliders. And I can add these to the window using add elements. So under UI main, add elements takes a reference to a window and a list of UI elements, and now it'll publish them to the window. Now, this still requires a little bit of setup because you'll notice that if I move this slider, it's not actually affecting this one. There are ways to do that, but they're a little more advanced. So instead, probably the easiest thing for us to do is to slap a value listener on these elements. So value listener is responsible for taking a list of these human UI elements and reading what their current value is. So this will update as I interact with the window. So this is going to change the number of sides. Also, you'll note that the range of each slider is inherited from the range of the sliders that you created in Grasshopper. So because the minimum number of sides is 3 here, I can't go below 3 in the UI either. So that's how you can kind of control those parameters. So we're going to take these resulting values, and probably the easiest thing there, but you could flatten this and get lists by item. I'm just going to use explode tree, also known as bang. And because it's put each value into its own branch, I can right click and choose match outputs. And then I just have to know kind of like which order those go in. But I've been pretty consistent. So I can say this is the radius, this is the sides, this is the height, this is the twist. And now I can adjust this tower using the UI without even touching the Grasshopper window. And if I right-click the launch window component and choose it to be child of Rhino instead of child of Grasshopper, it'll relaunch. But then when I minimize the Grasshopper window, so I can bring over, my principal or, the design lead on the project who is scared of Grasshopper, and just show them this and let them play with the parameters of the script that I've built without having to look at Grasshopper or be intimidated by their inability to play with Grasshopper. So thinking about an interface as itself a kind of collaborative strategy is I think kind of fun. And if there's interest in this, I can definitely do some future webinars that go into a lot more depth with Human UI. Human UI is a huge topic. There's a gazillion components. There are a gazillion strategies. There are all kinds of advanced things you can do. But that's probably the minimum viable Human UI for Grasshopper script. So let's see, we've gone over annotation, we've looked at clusters and user objects, we've looked at UIs, we've looked at snippets. The next thing I want to show is a couple different mechanisms for getting data all the way out of a Grasshopper definition. So I work right now as a software engineer, and the way that we're able to build complex software systems is by dividing and conquering, by having different people building different parts of the system at the same time. And so, and we all, we're all messing with each other's code and everything. So it's not like individual owners, but at least there's this notion that kind of individual parts of the code base are responsible for one thing at a time. And Grasshopper is actually not very good at this. It's very hard to have 3 people working on the same project in Grasshopper where one person is building the massing strategy and another person is building the facade strategy and another person is building, the area takeoff calculation or whatever. So I want to show some ways of thinking about approaching that in Grasshopper. So some of these are going to be file-based, which are going to rely on the kind of possibility of some kind of common server. This is kind of the dumbest, most old-school way to share work. And I think a lot of firms still work this way, where you have, the central server, the X drive, the B drive, or whatever, that has all of your stuff on it. And so this is a strategy that works really well in a scenario like that. So I'm gonna just save this as a Human UI example. Also, for those who are interested in poking around or playing with these examples, I'm gonna share the Dropbox link to this folder so you can play with some of these, and we'll be exploring a bunch of stuff in here. So what do I call it? Oh, here it is, Collaborative Grasshopper. I'm gonna copy the Dropbox link, and then I need to go back to YouTube, and I'll paste it in the chat. And I'll add it in the comments to the YouTube video recording when I'm done as well, for folks who want to play around. So I'm gonna now reopen the file called Twisty Tower. And what I want to do is build I'm working on the massing. That's my responsibility on the project. But my friend over here is gonna try and do some facade studies on the mass, but he doesn't want to wait for me to be done with the massing. He wants to start. And the beauty of computational tools is that, at least in theory, you should be able to be working on these things simultaneously, and downstream operations can respond to upstream changes. So his facade tool should be able to respond to, my massing strategy, and maybe my massing strategy refers to somebody else's program spreadsheet or something. So one way to approach this, which was actually a fairly late addition to Grasshopper, is to extract data and geometry from your file via what are called data outputs. So if you search for output, there's a special component called a data output that ships natively with Grasshopper now. And it will allow you to specify any number of pieces of information I'm just going to use 1 for now. Give it a destination, so I can right-click and say, now put this here. And I'm going to call this tower mass. You can see I was playing around with this earlier. So I'm going to have this stream to a .gh data file that encodes all of my geometry. I'm going to replace it. And it's just going to stream to this. So every time I make a change, it's going to alter that file and basically encode all of the geometry. And then my friend over here, who happens to sound a lot like me, can start building a new definition called, facade strategy, using the mirror image component of that one, which is a data input. So data input will let you right-click and set a source, and I'll say tower mass. And it's going to load in that geometry just the same way it came out. So we could be streaming to the same, or I could be streaming to a GH data file on the Q drive, and my colleague could be reading in that data from the same file and doing work, and we could together be building up a project. So what I can do is let's build like a little facade on this guy just for fun. So I'm gonna deconstruct the brep. And I'm going to get its U and V dimensions. And I'm going to divide U and V by some sort of like panel size, which we'll set to like 0.5 for now. And I'm going to divide U and V by the same, let's make another slider here so we can divide them differently, U and V. And then I'm going to do a divide domain that's going to take the domain of each of these surfaces. I'm going to graph them so that they each live on their own list. And I'm going to say take each one of these surface domains, divide it by this many U's and this many V's, which is going to create approximately even subdivisions across all the faces. And then I'm going to use those subsurfaces to kind of, or those subdomains to extract subsurfaces. So we'll say subsurf or isotrim is another way of calling this, where you'll take a surface and some subdomain of that surface, and then you'll get out a bunch of individual surfaces that take up that space. So I'm not going to talk a ton about this in particular. This is mostly just here to be an example, but this is like the world's dumbest panelization strategy. So the last thing we'll do is we're going to get the center of the surface. I'm going to use surface center from Wombat, but you could also just evaluate the surface at 0.5, 0.5. That looks crazy. We're going to hide the preview, and we're going to scale these surfaces about their centers by 0.6 or something to get our little windows. Regular Santiago Calatrava over here. And then if we want to just fill in the kind of gaps between the outer boundary and the inner boundary, I think what I'm going to do is merge each of these together and loft them. But in order for them to loft, right now I've got a bunch of items. So what I'm going to do is graft the input lists for both of these so that I wind up with a bunch of lists of 2 items apiece. And then I'm going to loft. And if I hide everything else, now I've got my little, like, facade. It's beautiful. This is going to win a design award, I'm sure of it. So the cool thing is, the whole time I've been doing that, my colleague Andrew has been redesigning the massing and twisting the facade a little bit differently and maybe adding a new side. And by default, the data input will not refresh. However, if you right-click and choose delay, like short, long, or medium, I think by default it's set to never. We'll do short just to demonstrate. And then after you do that, I've found that it's helpful to select it and choose enable, right-click the canvas and choose enable, because sometimes it forgets to refresh unless you've done that. And yeah, to answer Michele's question, you could save the data in the cloud. The tricky thing is, like, this expects there to be a file to reference. We're going to be looking at speckle shortly, which is a sort of a similar tactic that's kind of cloud native. So yeah, you do need to at least have some kind of a file mirroring strategy. So I've done this with Dropbox. So sometimes you can you can put, if everybody has a shared Dropbox, then everybody can point to the, copies of the same file and let Dropbox handle the synchronization. So because I set this to a delay of short, it is now actually polling the file for changes. So let's make this opaque just so we can see. It's a beautiful pink tower. If I make a change here, meant to make it a pentagonal tower and make it a bigger radius, then if I go back over here, it's already picked up that update. So the delay just says, how often do I go check for a new value? If you have a slow definition, you might not want it to be recomputing all the time. Or in fact, you may just want to explicitly go get the updates from it. So I think that's a pretty cool strategy. And a similar and related strategy, in fact, the way that you build your definition is very similar, but instead of using files, you're kind of streaming your data to the cloud, is to use Speckle, which is a really amazing open source project. It's really powerful, and you can get really far just using tiny pieces of Speckle. Speckle can be pretty complex, or at least it has lots of potential in many different directions, but you can do a lot with just 2 components from Speckle. So you have to run an installer from Speckle, and you have to set up an account, so I won't show all of that, but it's pretty straightforward to use. When you, and actually, I think Speckle right now only installs itself for Rhino 6. So I'm going to go ahead. I opened up Rhino 6 over here. So what I'm going to do is I'm going to take this definition, which I called Twisty Tower. I'm gonna get rid of my data output, and I'm just gonna save, and I'm gonna close it, and then I'm gonna open it over here in Rhino 6. And with Speckle set up, I can create a Speckle output, and I forget how they call it exactly, a data sender. So when you first set up Speckle, it'll ask you to log into your account and stuff, but then it becomes able to access what's called a stream, which is like a store of data on Speckle's own server. If you're using this professionally, you can also set up your own Speckle servers, which you have control over. So because it's open source, you can actually set up an entirely private infrastructure to do all of this. But it works in a very similar way to the data inputs and outputs. You can name your stream. So I'm going to call this, my Twisty Tower. And you can add additional data points. And I'm just going to feed it this surface. And Speckle handles serializing or translating your geometry into a kind of basically into a big ass text file, streaming it up to the cloud, and then making it available to other Speckle users and components. So this is a good way to share maybe with remote collaborators where you don't necessarily have shared file access. It's also a really great way to get data from a platform like Rhino and Grasshopper into other platforms. There are Speckle integrations, I believe, for Dynamo and Revit and other things. I haven't kept up with the development, but I know that it's capable of translating into all kinds of other formats as well. So it's really good to know about. But let's just pretend that now I'm on a new computer, or let's go back to our Facade definition. And just the same way I would have used the data input, I can use a data receiver from Speckle. And the one piece of information I need to do this, and there's probably a smarter way to do this, is I need this funky string, NEKHLGW, whatever. But if you right-click the component and choose Copy Stream ID, then you can, send that in a chat to your colleague in, across the world, and they can paste it here and plug it in, and then it will basically acquire all of the necessary information about that data set. and load in your geometry. And it even handles serializing and deserializing the data for you as long as deserialize object is checked. I haven't played with this. I'm curious what happens if you don't do this, although I have a suspicion. So right now we're getting a brep, which is the, a kind of a poly surface for Grasshopper. If I turn this off, it's a speckle brep, which is the way that speckle encodes this geometry and information. So, and you can get, I think, really, really complex with this stuff. You can have all kinds of like nested streams and keys and values and all kinds of stuff. But for my purposes, it's always been powerful to just, send data from one place to another as a collaborative strategy. So let's turn back on deserialize objects and let's pass this in. And the other thing that we can do, and this actually works with both of the strategies that I've shown, is I could say, okay, we're going to use a data sender on this end. Whoops, not that one. This one, data sender. This is going to create its own stream, and I'm going to call it, Facade. And I'll plug all of these in. And now back across the other side of the world, I could actually use my receiver. And of course, I'm going to need that ID. Ask my friend for it in the chat. Copy the stream ID. And we'll paste that here. And it should actually pull that data in. So in fact, I can be inspecting and visualizing the data that's coming back from my colleagues' work, and they can be looking at the work that I'm doing simultaneously. I bet this is like a progress bar. BREPs are generally like pretty heavy geometry, so I bet if I just turn it into a mesh before I send it, it'll go faster. That would be my guess. In fact, we could do a mesh join on a flattened list, and that'll probably go even faster. Let's see how we go. Data sent, it says. Now, back over here, it's getting these objects. It's giving you a little like status update down at the bottom. And I believe when it's done loading, 0 out of 650. You know what I'm going to do? I'm just going to re-instantiate this receiver because I'm impatient. And I think hopefully it'll just grab that mesh. Getting objects. There should, because I joined the mesh, there should only be one object, but it might still be stuck in a cycle of updating. I could also, I can use the same strategy that we showed before and pass this into a data output that I call Facade. Set my destination to be Facade data.ghdata. And I have to give it a name, which is like, Facade panels. And then enable it. And then let's see who wins. Oh, it's still loading. But I can do a data input and go pick that source, Facade data. And because this is just reading from the local file system rather than like going all the way to the web, it's much faster. But of course, it does require that, everybody have access to the same file system. So, now I can be keeping an eye on my colleague's Facade strategy and realize that, actually, I really want this to be a hexagon. And at least in theory, this is going to, take that change and pass it through that data file or pass it through the speckle server, as the case may be. And then, as long as their computer is on and running and ready to receive the new information, it can produce that update and send it back out. So back over here, we'll get our new hexagonal Facade panels. Marco wanted to know if two different people can get the same ID. I'm not sure. My gut is that IDs belong to streams rather than to individuals. So I think multiple people can be contributing to the same stream and reading from the same stream, but I don't know how it handles things like conflict. Like what happens if, you pass data to the stream and then I pass data to the same stream, if they overwrite each other or what. I'm sure the people who've built Speckle are all super smart, and I'm sure they've figured out good strategies to that, but I haven't used it extensively enough to tell you. When I was working, the last time I was working for an architecture firm, Speckle was still pretty new, and we were using a system like a system called Flux, which did a lot of similar things, passing data back and forth from kind of computer to computer and definition to definition. And so I'm less familiar with Speckle, but the concepts are very similar. So, okay, we've looked at kind of like sending data from one definition or one person to another via files and via Speckle with the cloud. I'm going to switch back over to Rhino 7, and I'm going to show a slightly different strategy. So I'm going to keep using these twisty tower examples. So let's say I made my, actually I already have a cluster of this, right? I have a twisty tower cluster. And so actually, yeah, let's do this in a new definition. Twisty tower. And I'm going to say it's got a radius of 1.4. And it's got hopefully some default number of sides, but it doesn't because I didn't set it up right. But you all know how. Height of 10. And a twist of 0.3. Yeah, maybe more than that. Maybe 1.5. There we go. That's nice and twisty. Also, I'm going to get rid of this fillet radius. We're just going to make it nice and simple. So I showed you before that you can save a user object. And I mentioned that user objects sort of don't have any, like, they don't update when you make a change. There's another way to turn a cluster into a file, which is actually fairly different. Which is to right-click a cluster and say export and reference. And when I do this, in fact, I already have a copy of this one here, I'm making a .gh cluster file. And in fact, you can use the one that's in the Dropbox if you visit that link. And you'll notice that now when I hover over this cluster, it points to that file path. And I'm going to do this also with my facade logic. So I'm going to say, okay, let's go to our facade system. And the facade system is going to generate, I'm going to take this much of it. And I'm going to expose a few things. I'm going to leave a few things hanging out, which control the window size. And I'm just going to create data parameters as kind of like placeholders in here as a way to designate what I want my inputs to be. You can do it a few different ways, but this is the way that I like to do it. And then these are the U divisions and the V divisions, which will control like the size of each panel. So if we want like wider panels, so we'll call this width. Actually, we'll put a data param, call that width. And then we'll do another one that we call height. And the last thing, I'm going to get rid of this as well, is I'm going to create a, these are going to be my, my tower mass. And I'm just going to make another dumb copy of it because the quickest way to produce your cluster with inputs and outputs is just to not select the parts that you want to be designated as inputs and outputs and leave wires hanging out of your selection. So that's typically how I do it. You can also go in and explicitly add cluster inputs and outputs, but I like to do it this way. So now we've got another cluster, and I'm going to call this, you know, facade panelization. And I'm going to do the same thing. I'm going to export and reference and call this facade panelization.gh cluster. And so because my friendly colleague has done this for me, has created a GH cluster that encapsulates this logic, I can just drag and drop this cluster into my file. You'll notice it'll always come in called cluster, which is annoying. But it does retain its reference to that file, which means I can plug in my tower mass, and I can set a value of 0.6 for the height and 0.8 for the width and a window size of 0.5. And I should get, let's do a custom preview on the other side. So now I'm actually using my colleague's logic in this definition. And so if my colleague back over here makes a change and says, actually, I'm going to generate a new output, which is going to be like the area of every panel, let's say. When I save that, it should have updated the file as well, which means that when I go back over here, so I've been working on this, I'm pointing to some file somewhere. This is another one of these scenarios where you're going to want your GH cluster files to live on a server where everyone has access, or at least on like a Dropbox where you have kind of parallel copies. It's going to change into this zebra stripe to warn me that this is now out of date. And I may not care. I can just kind of keep working if all I wanted was like a preview. And in fact, the geometry should still be there. So if I do, if I want to make my panels blue, I can actually still use it. But if I want the latest and greatest, I can right click and choose update. And it will go pull that in. And you can see now there's an area output. So now I can use the changes that my colleague made to their logic in the context of my definition. So this is actually a kind of interesting way to collaborate. You can build a master definition like this one. And so we'll call this master definition, which sort of orchestrates together a series of clusters, which each represent some piece of the logic of the system. And then I can be over here making changes to the twisty tower and say, actually, we do want that fillet radius in here of 0.1. And hit save. And then my colleague can have a copy of that cluster over here. So my colleague can actually be opening, their version of the master definition. And yeah, let's go ahead and do this. And let's also save it as like I'll put my initials on the end so that I know that this is my copy of the master definition. But I can pull in the logical changes from the system, and I can just go about my merry way. Now, changes like, if I'm over here and I change the number of sides, that's the kind of change that won't propagate because it's not contained within the cluster. So in fact, you might want to cluster the whole thing, including all of the variables that matter. And then you can, basically everything inside a cluster will remain synchronized between copies of the definition. So this is another way to approach kind of sharing code with Grasshopper. And I will confess, I haven't used this a ton in production. I always kind of tried to get this going. And I even taught a workshop about it at Acadia, like back in, God, what was that? 2014 or something? Maybe even before that. But I've always thought this idea was a pretty powerful one so that you could have multiple people kind of building up a more complex model, but having different people have ownership over the different parts of the code and in a way that remains synchronized across all of the copies. So let's see. The remainder of this, I have one more thing I want to show, which is actually not a Grasshopper thing, but I just think it's really cool, which is Modelo is a really interesting way to collaborate around 3D models. And they've been generous enough to offer free 6-month accounts for students and teachers. And so for any of my Columbia students on the call, if you would like access to Modelo, just in Slack, shoot me your Columbia email and I'll add you to our account. But what Modelo lets you do is share models and mark them up, do kind of like collaborative commenting and annotations, and even sketch over the top of 3D models in a 2D way. I don't know why this is going so slow. Maybe I'll let this load in the background. But it's a pretty cool tool, and it could be used for, kind of, oh, here we go, doing like, sharing work with your, during a review. Oh, that is not my email address. My email address is yeah, that's correct. And so I can take a model, and I think it doesn't accept 3DMs if I recall, but it will take like, it might even, but it will take common formats like OBJ and 3DS and other kind of like, I think it'll do Collada among other things. So this is my model. And you can have multiple models, I think, per project. I'm not a Modelo expert, by the way, but I wanted to give them a shout out first because they've been so generous with the students at this time, and also just because I think it's a really cool tool. But it's probably slow because I'm streaming. That's probably why. But in any case, these are kind of like fixed 2D views, which I can sketch over. And I can also view it in 3D and orbit around the model and attach comments to the model in 3D, which is pretty cool. So I can see that someone's left me a comment saying that part should be bigger. And I can say, okay, actually, what I really think for this project is, and jump into a sketch mode and say, actually, you should make this part like this. There you go. And I can add a little tag and say, well, I think I can add a tag. It's probably just my slow internet. But in any case, you can add little annotations, you can mark things up, and all of this stuff gets saved together in a way that multiple people can be kind of working on the project together in a 3D way, in a way that allows them to, kind of like add reviews, add comments, add thoughts, and collaborate usefully. It'll do walkthroughs, and it'll do nice stuff like you can do like section cuts through the model, which is really nice. So if you have like a pretty detailed architectural model, you can actually like get into the interior. It's really tailored to architectural collaboration. So I think it's pretty clever. Okay, so that we've been in for an hour, and those were kind of like the practical solution. So if you're all business, then that's probably all you'll care about from this. But I also, because our class has been looking at kind of inventive ways of using and abusing tools for kind of creative collaboration, we've been doing like, creating drawings together on Google Slides or with like Zoom annotations and stuff like that. I wanted to kind of expand that thinking and look at ways that Grasshopper enables kind of unusual or maybe slightly outside the realm of practical solutions for or strategies for collaborating. So one of these, and I'd like these to actually be interactive. So this is the moment where we're going to get into the fun stuff, and I want the folks in the live stream to participate, hopefully. So who knows how this is going to go? Hopefully it will work. But I think it's going to be fun. So I am going to go to Airtable. And I'm probably logged in as me, aren't I? I'm going to have to log in as my Columbia self. And hopefully the internet will not be too painfully slow at the moment. Yeah, let's log out and log in. So what I would like to do is have you all fill out, oh no, does it not have my Columbia login? Let's just, oh dear. Well, here's what we're gonna do. I think I can switch over to the Mac side. Hold on one second. What happens if I do this? audio capture. Yes. Let me just make sure that this is working. Hooray. Okay, it looks like it's working. So what I'm going to do, you should all be able to see my screen. And oh, and I'm going to need to turn off my own audio so that I can't hear my own voice. Okay. Whew. All right. Okay, so what I would like to do is have you all submit towers to my Airtable. This is going to be the simplest version of this. So I'm going to give you, oh, I guess I need to do the share link. So let's copy this. And you should be able to, where are we? Here we are. You should be able to fill in a value for your the number of sides, the radius, the height, the twist, the color, and then put your name down. And then we are going to actually like pull that information in. And I'll show you how to build this in a second, but I think it'll be fun if we just kind of let it set up live. So here's my perspective view. I'm going to go to a shaded view. There they all are. And we'll see if we're getting inputs. Because I have this set up to pull via the API the latest values in this table. And we should be able to update it on the fly. And in fact, and this part was not working, so I'm not going to use the actually, you know what? Yeah, here we go. Okay, so there's a few. So I'm going to refresh this. And if this dies, I might have to switch back over to Windows because this is what happened last time. Okay, I can already tell this is going to switch. So this is going to die, so we're going to switch back. Okay, we're back over on the Windows side. And I'm going to open up that same file called Towers from Airtable. And look at that. That's what I'm talking about. We've got a little gallery of towers popping in here, labeled with y'all's name. Let me just make sure the stream is still working. Yeah, okay, cool. So, and I can even, if I'm feeling really brave, I can turn on this little timer, which should go and fetch any updates as they occur. And it sure looks like it's working. I mean, some of you've got really, really big towers. So maybe I need to change the spacing of this a little bit so that we can see. That's better. But yeah, this is a, and maybe yeah, that's probably pretty good. So we can enjoy everybody's fine design work here. I don't really know what kind of like real world scenario this would be useful in, if any. But the idea of being able to like pull input from a group of people via something like an Airtable form and then let it drive. Oh, and I can't tell it. Adam's trying to go real tall. I see you guys with your big numbers. It's not a contest. You're gonna burn my computer down. So you can imagine being able to kind of like bring in data from an outside source and use that as a way of interacting. So you know, it's you know, I think there are lots of ways that you could kind of tweak this and make a kind of novel means of interacting with your Grasshopper logic by consuming, inputs from some form or whatever else. And if you're working with your colleagues, they don't actually have to do it via the form. They can go in and like edit existing values. So you could list every floor area in a tower in a Airtable, and as things are changing, just dynamically pull in the latest and greatest values. I'm going to set this back to 10 seconds just so my poor computer doesn't explode. So that's looking pretty cool. We got what? We've got our, let's just see how many we've got. Because I can see, I'm looking over at the other screen, I can see that I've got 22 of these. Yeah, sweet. You're all in there, I promise. Yeah, the one thing that Airtable doesn't let you do is specify like a color input. So what we're doing is we're taking the color text values and letting those automatically convert to colors, which is why in the guide it tells you to like use a kind of common color name. But you can get a little more out there. I think it's any of the like Windows system color names. So you could do like chartreuse, or here's a table of all the allowed colors, I think. Let's drop this in here. So if you wanna get inventive and make something that's pale goldenrod, you can do that. The other thing I could do if I wanted to prevent my computer from exploding is I could take the last 10 off the list. So I could reverse the list, assuming I don't actually know what order they come in, but let's try this just to keep things, because it has to recompute all of them every single time. And then we'll reverse it again and plug this in. Does it look like that's the latest? Oh, and I have to use that as well. There we go. It looks like those are the most recent ones. Hard to tell. If I were being really fancy, what I would do is I would sort by the created time, which is a piece of data that we get back out of the record. What the heck? Let's just do them all. But I will have to like stop this at a certain point. Oh, and this too. This is fun. I'm into this. And here I thought everyone would just make like, little tiny towers. Of course I should have known this would happen. I am the tallest is really, really pushing it here. Oh no. Oh, we've got the spinny wheel. Oh man. All right, I'm gonna turn off the global timer switch and hopefully we'll catch up eventually. So this is a good way to crash a gullible person's computer. But I also want to show you how we built this, because it's there are some cool tools involved in getting this to work. So come on. All right, we're doing a force quit. Sorry guys. I hope you got to see your tower. I hope it was fun. Yeah. Okay. Whew. So let's talk about how we built this. So there is a plugin that lets you speak to Airtable called Mallard by my friend Nick Kassab. But we're going to be using a slightly simpler tool right now. His is really powerful and it'll let you like update the fields and do all kinds of stuff. And this one is a little bit jankier. But I think it's going to be simpler to set up. So I'm also going to do a very naughty thing, which is I'm going to reveal my API key to you, which you should not do because anybody who has access to your Airtable API key can like do anything to your Airtable data. So if you're a real hacker, you can get in there. But so one moment. I need to figure out how to get this data over from the Mac to myself over here. Oh, I know what I'll do. So 1 second. So what I want to do is I need to grab, whenever you're in an Airtable table, oh, here I'm demonstrating, of course, on the wrong thing. Hold on. Let me see if I can log into my other Airtable, and I'll just grab the, so it should be, and then what's my password on this one? Did I not save it? What did I do? Sorry. Somehow I managed to like sign up without saving my, oh, I know why, because it's a sign in with Google. I'm such a dum-dum. And of course, this is going to be fun. And whatever my, hold on, sorry. Oh, come on. Hopefully this will work. Yes, try that. Yes, it's me, I promise. And we're in. Okay, whew, sorry, that was more involved than I thought it would be. The thing I wanted to show you is that if you go to the Help tab in an Airtable, you can click on API documentation. And what it will show you is all of the necessary code for getting access to the data in your Airtable from other sources. And it'll document it with a number of methods. There's curl, which is how you can access it via the command line. There's JavaScript. And the one that we care about, you'll want to scroll down with curl enabled and find, yes, the one where it's under authentication where it says example using query parameter, and then check show API key. And at the end of this video, I'm going to go change my API keys so you can't go like hack my Airtable. So I'm going to grab this whole string, and I'm going to use the CS Vultr plugin, which has not really been widely publicized, but it's a tool for accessing like CSV and tabular data, but it also has just like a utility tool for going to get some data from the web. So I think it's just called get from web. And I'm going to use this URL, which says, and CS Vultr, for those who maybe joined late, you can add it via the package manager. It's not even on Food for Rhino. I've basically only been publishing stuff via Yak lately. But I'm going to take this whole URL and I'm going to plug it into get from web, and it's going to spit back a sort of JSON or JavaScript object notation representation of all of the data. And this is where we're going to use another plugin, also on the package manager, called JSON, which is designed to allow you to deconstruct data in the JSON format, deconstruct and construct. So it's really good in this particular scenario. So we're going to use the deconstruct JSON, I think it's called, or deserialized JSON, which is going to take all of this text and spit out a value which corresponds to the key under which all of that text is stored. JSON objects are kind of like nested dictionaries with a key and some value, but that value can itself have additional keys and additional values. So we end up making multiple copies of the deserialized JSON component, and this will take all of the items in the list of records, and it'll give me back all of the fields. And then I can grab all of the items from all of the fields, and it'll create values on the out, which correspond to all of the columns in my table. So in fact, I could add a new column here, and it would show up. And I can see we've got now 35. So this is fun. So the way that I built this is I just took each one of these, and what I think ultimately I grafted the fields so that they would be on their own tree. Deserialized JSON should be pretty forgiving about data tree structures. So I'm going to create a polygon. Actually, I'm just going to use my Twisty Tower user object. It's got sides. it's got a radius. Too many of these. Of course, I'm gonna be subject to the same problem here with you and your gigantic towers. Although I can't imagine that anything. I'm gonna delete the field with the 100,000. Sorry about it. Although it might be too late now. Let's see if we can escape out of this. All right, we're gonna quickly spin this back up in another instance, and I always play the rhino race, where if something feels like it's about to fail, I spin up a new rhino and see if I can get back to where I was when it was failing faster than it can finish computing. So we'll do it in 2 views and see what we get. So, okay, we need a grasshopper. And I think what I'm going to do is reopen the definition and the one from Airtable. Oh, that's interesting. That's new. And I'm just going to turn off the timer on this before I let it solve. And I'm also, yeah, this one's set up with the kind of pure logic. Let's, none of this should be too crazy. I mean, the loft is definitely going to be the most expensive operation. So I'm going to disable it. And everything else should be pretty chill, right? Yeah, why not? Let's try it. So here's all of our geometry. Okay, so now we can kill this because we're basically back to where we were. And I can make this bigger. So it's generated all of these. I wonder why the loft gets slow with the big operations. It really shouldn't. What about a mesh loft? Except I tried this earlier and it didn't do a very good job. I don't really like this component. Here's what we're going to do. We're going to cheat. I kind of, oh, you know why? I bet it's large side count values. What's the range on this? Yeah, that I didn't think of course. That makes sense. So if we, yeah, 100 sides is probably too many. So I think what I'm going to do, and this is what I should have done in the first place, is set a min, which will return the smaller of 2 values. Whoops, not a Minkowski sum, just a min, where the side count maxes out at 20. And the height maxes out at, let's say, 100. And the radius maxes out. I don't see why the radius should actually matter that much, but I'm going to have it max out at 102. Sorry, guys. Okay. Can anything else? Twist I don't care about too much because that should be okay. So, yes, I can see a lot of 100s because you all put some very large numbers. Thank you very much. So the thing that I wanted to show, so first, let's just see if our loft works. Actually, let's save this before I do that. It should be able, yeah, see that? It did no sweat. So it must have been, I think it was the side count. I think that was the big deal. So maybe we can try easing some of these restrictions a little later, but in any case. So the tactic that I wanted to show was basically taking the list of records. So I have how many records? 35 records. And then I'm creating a grid over here just using a series, and I'm grafting the Y and not grafting the X so that I get a grid of points. And then I'm flattening this list with a P shift, and then I'm taking the shortest list to give me the first 35 points in that grid. And then I'm just moving all of my lofts, which all get constructed in the same place, to those locations such that I have like a grid of all of the towers that got created. And in fact, because our max is at 100, we should really like maybe up this spacing even further. And so now we've actually like, I think we've fixed this now. Dan's got a really long, really long text string. I like that. That's a clever way of breaking the system, although it doesn't seem to have broken anything too hard. So here is our little gallery of towers who are looking pretty cute. And then I've just created some text tags over the top of each one. So it was mostly just that, the kind of like using the shortest list with a grid of the ultimate locations as a strategy that I wanted to show. And, you know, if we wanted, we could, as long as we could like arrange it in a 7x7 grid or whatever. Yeah, so that's cute. Oof, okay, that was fun. A little harrowing there for a second, but we got through it. This is pretty cool. And the other thing, so another kind of fun group project, let's say, that I wanted to try was actually inspired by some student work. One of our teams, or one of our groups of students in the class, were over Zoom kind of sharing, like they were basically modeling the space like a certain distance in front of their desks in Rhino, and then assembling them all together into this like giant lattice of like their desk environments, creating sort of like a virtual architectural environment of kind of everybody's collective workspace, which I thought was really cool. And so I'm going to show a kind of variant on that, or a little exercise that's inspired by that. So the next thing that I'm going to need to do is give you a template file. So I'm going to paste into the chat a link to a Rhino file template. And this is going to include within it a box. That template should really just be, if I open it here, and I believe it's a Rhino 6 model. If you have trouble opening it, let me know. And yeah, so Adam, who's in the chat, was one of the students who worked on that project, and he's explaining it was a 6x6x6 foot cube in front of wherever your webcam was, which I think is really clever. So the idea here is that you have a boundary, which is this black box, and then you have your model, whatever you want to put into the lattice, on a layer called your geometry. And I can already feel this crowd itching to break the rules. So we'll just see what happens. I'm not gonna get overly strict, but like let's try it drawing within the lines to start, and let's not put any like massive 1,000 megabyte models on here, please. Just do like a little BREP model. I think meshes should be allowed to. But like, yeah, don't be mean. Don't try and crash my computer. So model whatever you want in Rhino on the your geometry layer. Oh, and yeah, I mean, I wasn't saying that yours has to be whatever's in front of your webcam. Like it can be whatever you want to model for now, as long as it fits within this box. And maybe I'll even get strict and reject models that don't fit within the box. So, and so when you are finished with that, what I would like you to do is submit it with your name to my Dropbox. So I've created a file request on Dropbox, which I am just going to go fetch right now. And it should be a sort of like, yeah, here we go. Drop files here. Let me get the link. Hold on. How do I get the file requests? Email link, copy. Okay. So this link should take you to a Dropbox link where you can upload a Rhino file. And so please drop a model here that is based on this template. And while we do that, what I'm going to do is go look at that file path over here on my system. So every file that you drop in should get created in this folder. And so what I'm going to do is use human to do a directory contents. I'm going to find files that are of type star.3dm. So I can put a filter on directory contents from human in order to grab all of the files that match an extension. And this is going to give me a list of all of the Rhino files in that folder. And let's just check. It'll probably take a second for folks to finish modeling. And then I'm going to use another component from human called read 3dm file, which will take a file path. And this is where like you could probably like make my computer crunch if you were feeling ill-spirited. So I'm going to be optimistic about the good-natured audience we have today. And there are going to be objects on various layers, and I only want the stuff on the your geometry layer, which is the red layer, so I can filter by layer. And then I'm going to get a bunch of geometry coming out of whatever files are in there. And then what I'm going to do is I'm going to make a group out of this geometry such that each file becomes one object. And then I'm going to distribute them in a lattice. And I believe that this is 10 by 10 by 10, I think. Yeah. So what I'm going to do is create a grid using a series with a distance of 10 as the step size. And for fun, this time, I think what I'm going to do is I'm going to use cross-reference, whoops, not that, to generate a 3D grid. And then I'm going to randomize it. So this is where your files will wind up. Let's just see if we've got any yet. Yep, oh, we've got our first one. That's awesome. So let's just test this by rerunning it. And we should have now 2 groups. And I'm going to P-shift this. And I'm going to use, again, my shortest list strategy. And I think I'm going to jitter the points. And so then we're going to use shortest list on here. And we're going to use these resulting points to move our resulting objects. So nice. So we've got 2 files in here, but as y'all add them, so Adam's dropped one in. So I'm gonna to avoid the explosion factor, I think I'm gonna explicitly refresh just so that I can do a little bit of a check and make sure no one's like putting many gigabytes of data into this model. But like, you know, in the 10 megabyte range feels pretty safe. So we're just going to sit here and kind of watch this happen. And I'm going to make this pretty. So we're going to put it in with white. And, you know, maybe I won't jitter it. Maybe it's kind of fun when they go all together. That's looking pretty cool. Oh, I like the 3D zoom thing. That's cool. I also like where there's continuity. So maybe if you want to use some of the geometry that was already in there as a guide, you might have some fun with that. So, and I don't know to what extent there's like a delay. There's another one. We'll do a refresh. There we go. Oh, yeah. That's cool. Oh, this is cool. Oh, and here's the other thing we'll do. I'm going to do a zoom bounding box from Wombat on the bounding box of all the geometry. Whoops. And I'm going to set this to true. Oh, union box. There we go. So now whenever we get an update, and let me save this as, let's see. I think I had a version of this already, but it's fun to build it on the fly. The other thing is that if you are unhappy with what you submitted and would like to modify it, I believe if you drop a file in with the same with your same name and the same file name, I think it'll actually update. So let's refresh here. There we go. Oh yeah, this is cool. We're modeling together. And you know, if I were really on top of it, I could have set up like a speckle stream and had everybody like submit files via or submit geometry to one common speckle stream and have it all aggregate or whatever. But I kind of like how predictable the like file based approach is. Oops, keeps doing that. Yeah. I really, when there are like alignments from tile to tile, that's like really fun. I feel like that would be like another way to do this would be in the sort of like exquisite corpse concept where you maybe like define some geometries at the boundaries of the cube, and then you have everybody kind of model a cube that sort of seamlessly hits those boundary conditions. All right, I feel like it might be safe to put a timer on this. Don't make me regret it. Here's what we're gonna do. I'm gonna set it for like 30 seconds, I think. So what would that be? 30,000? Yeah. So every half a minute we'll get a little update. So that will be building itself. And I think, yeah, here's, if I do this, it's gonna keep working, right? Let's just try. If I make another copy of this file, will it show up twice? Yeah. Yeah. So this should just sort of grow while we're sitting here. So maybe I can like leave this going in the background while we look at our next example. So I might have lied about things updating. Unless you've been deliberately changing the file names, it looks like it's actually creating like multiple copies of stuff. But that's cool. So we'll wait for that one to refresh. There we go. Yeah, this is cool. I love this. I like that. Oh, the H is for human. That's good. I like that. I'll take it. Nice. This is sweet. These are so cool. I love what everyone's modeling. This is like fun. I'm going to have to make a drawing of this later. Yeah, I think there's something really fun about the moments of continuity. It feels really cool. So, okay, I think what I'm going to do, because I want to keep moving, is I'm going to try and size this window over here. And I'm going to, yeah, let's just do, probably hate myself later for screwing up my workspace, but let's just do this. I'm going to keep this window kind of like smallish on the side. And then I'm going to try and work with half a screen. So hopefully, if anyone's still working, hopefully you'll still see it show up over here as it keeps refreshing. But we're going to spin up a new instance. And I'll just keep it over here on the right. Because the last thing I wanted to show, this is a concept that I've been talking about with my fellow instructors of the course for a long time, and I've just been like desperate to do it. And I have no idea how well it's going to work. But in our course, we've talked a lot about the idea of the exquisite corpse. And I've always been interested in kind of like stitching together not just geometry as an exquisite corpse, but also like computational logic. Like what if everybody was responsible for building a script that had kind of common inputs and common outputs, such that they could be interchangeably hooked together. So that's the thing we're going to attempt to do. I have no idea how it's going to go. There is a Grasshopper template file, I believe, called Exquisite Corpse Template. And it should, I already posted this link, but I'm going to post it in the chat as well. Over on this side. But all this is a kind of preset, like empty cluster. And the idea is that you, my audience, are responsible for creating a cluster that takes in a curve or a list of curves and generates another curve or list of curves. And that's it. I imagine we will run in also here to some unpredictable like computation time stuff. So we'll see how it goes. But I've also provided some examples, and I'll post that link as well. There are some, so if you want to maybe take an existing one and modify it, that's also here. And the examples look like this. We're just going to go ahead and open it. Oh, this is my halfway built script. But each one of these is just a very simple cluster. Some of them are simpler than others, which does something to a set of curves. So if I have like a rectangle and a circle as my inputs, and maybe I'll explode this just for fun. I'm trying to work in now a quarter of the screen. So here they are. I can use like make perpendicular lines, and that's going to generate some perpendicular lines. And then I can use rotate every curve by 90 degrees, which will take those and rotate them. And then I can use move every curve to the location of the following curve, like this, and so on and so forth. And I can use zigzagify. And we can wind up with some kind of interesting geometry. So the hope is that we'll wind up with a library of functions that can be kind of like arbitrarily ordered. And if we're feeling really ambitious at the end and people haven't totally lost steam, and by people I also mean me, we can even try getting super fancy and scripting something that will actually like grab the clusters and execute them in a loop, rather than just like manually adjusting them. Ooh, this is looking so cool. I'm really into what's happening over on this side of the screen. So go ahead and take the template. Go ahead and build a definition that takes in curves and generate curves. Please follow the template because it forces us sort of flatten on the end. We don't want to wind up with some kind of combinatorial explosion. And then I'm going to create another Dropbox file request. And I'll send that to you. One moment. Oh, and the other thing is that I think it's going to be best if we do GH cluster files. So when you're done composing your script, put it into a like make it into a cluster, which you should be able to just select the entire template because it's already set up with the cluster input. So just like select everything, cluster, and then export and reference, and then find that GH cluster file and drop it in our file request. So okay, so I'm going to paste that link over here. And Dan wants to know, do we have any thoughts on keeping the same number of curves? I actually think it would be fun if some created many curves and some created fewer curves than they started with. I'm going to leave that up to you. It's going to be a little bit of an experiment. I can imagine we could wind up in a dangerous scenario if everyone's creates 100 curves for every curve it gets. But let's just see what happens. I'm kind of inclined to just see what happens. So in your Grasshopper rating, you should be able to add your GH clusters, and they should start to show up in this folder. In the meantime, while I wait for these to show up, man, I really need a bigger screen for this. I am going to attempt to finish a script that I was like scrambling to write in the like 10 minutes before the live stream started that would actually like execute a cluster for you. So apologies, we're going real deep now. But if we start getting some clusters in here, I'll pause and we can just like play with what we get. So, okay, scripting in the world's tiniest window. Okay, so we're getting a cluster into the component using MetaHopper as a way to like reference it. So we're going to select that cluster, pass it as a cluster object, and then in C# we can cast it to a cluster. We can get the document out of it with the document method from a cluster. We can find all of the objects of type GH cluster input hook, which is what these are called. We can clear the data in the input. We can add data into the input. We can tell the definition to solve. Every cluster contains a like virtual mini definition inside it. So we'll say that document is enabled, solve it, and then in theory, we can find all of the outputs. And this is where I stopped, which are objects of type GH cluster output hook, which is what these are called. And in theory, we should be able to get, and the other thing is I'm passing a new curve into the thing as my input C. And so I'm creating that GH curve and I'm actually putting it in to that input object. So the last thing I need to do is take my output, and there are two methods usually I need to call at this moment. One of them is gather, I forget what it, compute data. And there's one other that we usually use. And hold on, I'm going to go like sneak a peek at some places where I was doing this before. Oh, come on. Is that not what it's, it's not case sensitive. Is it not .compute data? Oh, we got one. Can't remember what this method is called. Gather, it's like gather data or something. Let's just try compute data and see if it's sufficient. So if we say a equals output dot volatile data, let's see what we get. Well, it's not too mad. It says there's no data in there, but that's not necessarily the worst thing. So I'm going to take Dan's wiggly line, and I'm going to take the inputs I created up here, and I'm going to find my Rhino window. I'm going to make this even smaller now as we're transitioning exercise. And so I've got a reference. I'm going to plug them into Dan's wiggly line. And now I've got some sweet wiggly lines coming out the other side. That's cool. So I don't know how fun the watching me script part of this is for anyone, but let's see. So let's use this new one. Let's use wiggly line as the cluster we want to solve. So I'm going to get a reference to it with MetaHopper select objects. We're going to take the curve that we're going to pass into it because we know that it should produce something. And then what are we getting out? Oh, there's something in there. It's a structure. So I believe we can just get volatile data dot all data. Skip null's true. Oh, no, hold on. It worked for a second, right? There was a structure. We've gone way deep now. So if this part is no longer interesting to you, I won't be offended. It's compute data, and then there's something else that we do that basically like tells it to, hold on, I wonder if I have an example in this code because I was working with, whoops, no, when I go gather the param value, collect data, that's the other one. I think that's the real one. Still no data. What are we getting out the other side? If we just get the volatile data. No, that looks correct. It's giving me a structure, a GH structure, but somehow that data is all null. We may not get there. This may or may not work. Oh yes, and if you want to, when you're ready to save that file, also I should be keeping an eye over here. Open your, and in fact, I'm gonna pull open Quentin's so that we can use it. Take your cluster and go export and reference, and then drop it in, and upload that to the file. So basically, like, make your cluster and save it as an external cluster, and then I can drop it in. It doesn't matter like that much, but now I should be able to just drag and drop it. And we should be able to take like Dan's, and now it's creating a bunch of little polygons around his wiggly line. We could also invert the order and take this and then make those, each of those wiggly, and we get like cool little stars out of them. I might just like grab another few of these to play with while we're down here. Oops. So here's our input curves. And we're going to do zigzagify and make perpendicular lines. And then we're going to run those through the necklace, and then we're going to wiggle them. Or maybe we're going to wiggle them and run them through the necklace. And then maybe we'll use that in tandem with offset many times. Whoa, too many times. Let's try make perpendicular lines off the edge of our necklace. And then let's try extend by 5. Now we're getting somewhere. That's looking cool. We've got a few more of these. Let's see what we got. So if we plug this one in here, ooh, this one's going crazy. Let's plug it in. Why not? Let's do it. And this is the part where my computer explodes. Oh no, it's doing okay. But we do want to make sure that everything's flattened. So I'm going to enforce that manually as well. So now we've made these wiggly, and now we're generating a pattern of these necklaces, making perpendicular lines from them and extending them by 5. Ooh, now it's getting real dense. Maybe we're losing some data. Maybe it's better without, or maybe we can try a totally different order altogether. Maybe we can, because zigzagify and perpendicular created a lot. Now we have maybe a fewer number, and then these are getting wigglified. That's kind of cool. I like that square that's starting to emerge. And then, yeah, there we go. That's kind of cool. But let's find something else. Let's here. Let's scale each curve by a random amount off the necklace. And let's see if we have any new ones. No, we're good. So what if we moved every curve to the location of the following curve? I'm not sure that that'll do much here, but we'll see. Sort of. Maybe we can turn those all into arcs. Maybe we can stitch something out of this. Maybe we can move this guy down towards the end. So now we've got wiggles, perpendiculars, extends, move every curve, make arcs. Maybe we can put our necklaces on top of our arcs. Oh, I also did not follow the rules and remember to flatten. I think these are pretty fun. Let's see if we've got any new ones. Oh. The funny thing is that they come in without names altogether. Okay, so I'm going to stitch this in and see what we get. Oh. Let's see. Oh, we got Python in here. Let's see why it's mad. It probably had some expectation. Oh, closest is not defined. Huh. I'm not sure I'm enough of a Python head to troubleshoot this one on the fly. I wonder, maybe a different curve input that's not a line would have worked. No, it still seems, I think it's a syntax thing. Let's try a fresh chain. Let's start over here. We've got these. We've got this one. Ooh, that's kind of cool. I like sort of some of the like simpler ones. And then let's do this guy. Ooh, getting hairy. And let's pick another one of these, like let's try oversimplify. Which sort of enforces a geometric rigor. And then let's make some arcs off these guys. And some perpendicular lines. And sometimes these things just look better if you make them thinner, when you have these really dense sets of line work. I also like everything in black, of course. It's getting fuzzy. I wonder, it's like maybe better back here. That's kind of interesting. Plug a Zigzagify in here. Anyway, I'm not sure when to be like done with this example. I'm going to open it up to suggestions. Well, first, let's just make sure I haven't missed anybody's clusters. Is there are there any other does anybody else want to drive? Does anyone have any ideas of something else we can do with this? We can play with different input conditions too. It would be interesting to see what would happen if you just started with a line. Step through these a little bit. Maybe not do this. That's kind of fun. Maybe, where's that necklace? I'm not sure which one is the necklace. Oh, I think it's over here. That's fun. Yeah, I mean, I think, like, philosophically, there's something kind of interesting about, like, there's an analog when a lot of like generative strategies involve some kind of like genetic algorithm where you are basically like, you're tweaking the sliders. Ooh, I like Dan's suggestion. Okay, cool. Let's do that. But I'm gonna finish that thought, which is that, like, we think about these strategies of kind of like altering the parameters of the definition as a means of controlling a certain type of change. But there's kind of like a next order genetic algorithm, which is genetic programming, which is where you actually like evolve a system by dynamically combining different steps, like actually like rewriting the algorithm rather than just tweaking the parameters of that algorithm. So there's something akin to that in a process like this, where you can kind of like iterate by testing different sequences of processes in a combinatorial way. So what Dan was suggesting, I really like, which is, and maybe we can get fancy here. You know that I love to get fancy. And what we're going to do is I'm going to take this sequence that we have currently. And I believe what we can do, this is probably, I'm probably getting too fancy, but we're going to go with it. Okay. Here's a chain that we selected. I'm going to make a group out of this chain. And I'm going to do objects in group from MetaHopper. I'm going to add it to the group. And this is going to give me back a list of, there we go, all of the clusters. And I'm going to get component info. And I'm going to just sort these by their X position. So the component info will give me back the pivot, which is where they live on the canvas. And then I'm going to sort them by their X location, just so that I'm sure that each cluster that I get back out is in the right order from left to right. Then I believe I can do another, actually, maybe we just need to sort the outputs. Let's just sort the outputs, and we're going to P-shift U, because there's only one output per cluster. And then I believe we can do get param data. Let's see if this works. We've got all of our params, and those are going to come out as data wrappers, which we can metahopper unwrap. And those are also wrappers here. Oh, did we do unwrap n? It should have unwrapped everything, but it doesn't appear it did. That's supposed to work. Let's just try a manual unwrap and see what we get. There we go. Beautiful. So the reason I wanted to do that is that each one of these branches corresponds to a step. And Dan had made the suggestion, what if you colored each step incrementally in shades of gray? So what we could do is we can take each of the components and we can take that list length and we can take a range that's x minus 1 so that we get a range from 0 to 1 for each component. And then we can pass that through a gradient. And we probably want it to go from darkest to lightest. I don't know why, that just kind of feels right. And then we can do custom preview line weights, where these are our shades, which I'm going to graft so that they match the data structure of all of this. And then I also think, just for draw order, I'm going to move these in the z, in the negative z, according to this same range, so that basically like the oldest ones are on top. And so what we should see, I think, is that, did I do it backwards? I think I did it backwards. Shouldn't this be, am I crazy? Oh, maybe some of these are already, maybe they're already 3D. Maybe that's the problem. Yeah, that's probably it. Sorry if I ruined anybody's three-dimensionality. But this will now actually, and let's use like let's use a gradient so we can see it happen. I kind of liked what was happening before, but I just don't want it to go all the way to white because we lose some stuff. So I think what I'll do is have it go to like a light blue. Something like that. So the cool thing is that this will now work for any chain that we make. So I went through that pretty quick. Let me recap what just happened. So I took this chain here and I put them all in a group. And then I used MetaHopper's object from group to actually get references to every component in the group. So I'm actually getting pointers to the components themselves, the clusters themselves. I'm using component info to get back out the locations of each one of them so that I can sort them left to right. And then what I'm sorting are the output parameters. And every single one of these has a single output param. So I'm sorting the output params from left to right. And then I'm using param data to get the geometry out of every output param. And then unwrap is handling actually like deconstructing that into real geometry. And then I'm creating a color. So, but the structure of this unwrap will have basically one branch per component. And so we can actually trace the question that Dan had asked earlier about, does it add or remove items? It looks like in this particular sequence, everything adds. Okay, we're mad about the 3D, so let's undo our project. I did like the 3D, but what we're gonna do is we're gonna multiply our Z stacking by like a large amount, just so that we get our ordering correct. There we go. That's a little better. But now we can even we can see each step See, this is cool. We can see the way that each subsequent step transforms that geometry. So this, and I'm gonna save this as whoops, not this guy. Save as MetaHopper view steps. We could do this with another chain. So let's take this one that we built earlier, and let's make a group out of it. And then let's use this component, which is get objects in group, and add it to the group, and it will just like list all of the objects in that group. And now we can use this same routine to visualize all of this stuff. So now we can see the way that each successive step transforms the geometry that it received. I think that's pretty fun. I don't know about you. All right, I'm not gonna dive back into the like remote solving script thing. I will, because if it was gonna be that easy, we could go with it, but I don't want to just like sit here and troubleshoot. And also, I'm kind of running out of steam. But I hope this was fun. Before I close, I would be happy to take some questions. Oh, you know what else we're gonna do? Sorry, I had one more idea, which is we should remap this from like 10 to 1 and make it line weights, because y'all know I love my line weights. Nah, too fat. That's better. So yeah, so I'd love to take questions, or ideas for other little quick experiments we could do, or other little tweaks. This is really fun for me. I hope it was fun for you. I hope it was educational. I hope it spurred some ideas about different inventive ways to collaborate with Grasshopper, both practical and impractical. Yeah, I'll stick around for a few more minutes. But thank you all for attending, and yeah, I look forward to seeing you at the next one. Let's see where our 3D landed. This looks really cool. I love this. Cool. Yeah. Thanks, Kristen. I would be super happy to do a human UI session. I'm a little rusty because I haven't been using it much for work for a few years now. But yeah, it would be fun to dive into that stuff. Yes, Dan, I love that idea. Well, that's what I really wanted to do with that script that I was like scrambling to edit to kill time, was I wanted to be able to like randomly order the cluster connections. I think it's a little hard to do that with MetaHopper currently because I don't think you can create wires. I don't think you can like, yeah, you can get the connectivity information from MetaHopper, but you can't set it. You can't say like, this is how, like, connect this output to this input or whatever. But by using a script that like just calls each cluster, we could provide it with a list of clusters and have it like randomly pick one and take the results and pass them through to the next one and stuff like that. We can also do that actually The way to do that without scripting is to, there's like a, this is actually the way that like tweet to form used to work, but I'll do a very, very quick demo. And here's what I'm going to do. I'm just going to like paste like 3 of these here so you can see the idea. So we're going to grab you. We're going to grab, I'm doing these one by one so that they lose their wires. Okay, I'm just going to do it with 3, but you'll get the idea. You can use a stream filter on one end and a stream gate on the other, and say like 0 is less than 2 is our gate. We can take some input curve like this. Produce 1 output per cluster. And then mirror over here on the filter using the same index. And then this is your switcher, like which process should I apply? And then, so you just have to manually go, 3, 4, 5, 6, 7, 8, 9, 10, whatever, and make all of your copies of all of your components, all of your clusters. But then you can, you could pull this into like Anemone, where this is your like input geometry. And let's just, for now, let's just use C as the driver. And we'll say, we'll do this for 3 steps. We'll do it for 3 times, and we'll do a loop end with the same geometry. And now what it's going to do, actually, let's set this back to 0, is it's going to run through, it's going to pick the first one. So this count is now driving which one we pick. It's going to pass that through, and then it's going to loop back around, and then where count is 1, it's going to pick this one, and it's going to take that and process it through. And then when count is 2, it's going to process it through this one. And then, so what you'd really want to do is like generate a new random number, like whatever here as your seed, and then do like mod however many components you have, which in this case is 3, and use that as the gate and as this gate, so that basically you can like loop through and have it like run these processes a bunch of times. And it probably, in this case, it'll fail because like one of the scripts is like failing at some point in the chain, but that would allow you to basically like sequentially apply, like pick an arbitrary operation and then chain it together in sequence. Rodolfo wants to know any tips for starting to learn C#. So this is a good question. I think there have been some good webinars on this, although I'm not totally sure off the top of my head. I think Long Wen has been doing some good like C# tutorials online for Grasshopper. But the thing that I'll say, the way that like there's really no shortcut to just like getting familiar with Rhino Common. And if you have been using RhinoScript syntax, then you'll probably have some like bad habits. This is not like necessarily a bad thing. I think it's a useful way to work, but you will have much more, you'll be able to do a lot more with Rhino Common and Rhino.geometry. So I would say like focus on Rhino.geometry, and then you'll find that translating to C# is really easy. And the other key tip, and this is like, I hope David Rutten's not watching this, because what we're about to do is technically a violation of the license terms of Grasshopper, but it's a tool that's been enormously valuable in my arsenal and in the way that I've learned C# over time, is that I use a program called ILSpy, which is effectively an assembly, it's a disassembler or a decompiler. And you can point it to any DLL or any GHA. So I can go find like a plugin over here One thing to know is that all GHAs are just DLLs by another name. So here, let's pick one that I wrote so that we don't get into any trouble. But what this shows you, this will actually like do its best to show you the code, the actual source for every component. So you can actually, the method you're looking for any given component is like well, and this doesn't have components, so that was a bad example, but let's use like triangulation components. So like, I want to know how isovist works. I'm going to go find component isovist, and then I'm going to go find solve instance. And this is where the actual code for that lives. Now, it's not quite as clean. It's not actually exactly the way that it was written. So sometimes there's a little bit of like variables are all called like num2, num3, num4, whatever. Also, let me reemphasize this. This is a violation of Rhino's license terms. Like, you are not supposed to decompile their code. But I think as long as you're doing so in the interest of like learning and building new stuff and not doing it to like steal or make copycat code, this is how I learned to write Grasshopper components. Like, everything I learned from David Rutten by decompiling his code and trying to like retranslate it in a way that works. So you can find out, okay, this is you have to kind of guess. Like, I don't know what, like, he probably gave the variable another name, but in the decompiler it loses the variable names in a lot of cases. So you have to figure out what the heck list2 and list3 and list4 are meant to represent. But you can at least figure out for simple components, like, let's say I don't know how to make a planar surface in C#, but I know how to do it in Grasshopper. I use the boundary surface component. I can go find component boundary surfaces. Here it is. And I can go to its solve instance. And sometimes you have to dig around. And this, like, learning to translate this is a skill in and of itself. But, oh yeah, and this one's actually extra complicated because it's a multi-threaded component, so that was a bad example. But ultimately, you can kind of dig in and find the method. And in this case, like, the key method is brep.createPlanar breps, and that's something that I can do in like a C# script. So if I wanted to take like a curve and make planar surfaces from it. Sorry, I drew that poorly. Let's take these and make that like, I don't know, a list of curves probably. Then I can do brep.createPlanar breps and then pass it in my curves. And it's done basically the equivalent of the boundary surface component. Now, boundary surface is much smarter than that. It's like checking all kinds of things, but don't worry about that for now. At least it's a way to figure out. I also highly recommend, my friend Guy has built a very nice searchable interface for the Rhino Common and the Grasshopper API docs. And this is also has the added benefit of not being illegal. So you can go search for things like planar breps or whatever, and go find the methods that you want with lots of documentation and eventually even like examples and stuff. So I hope that helps. Maybe I'll do another future session on like getting started with C# in Grasshopper too. Cool. Well, I think I'm going to end it there. If there are any last questions, I'll try and respond to them in the chat. But thanks again for coming. I hope this was fun, and enjoy the rest of your weekend.